Hello, welcome back, everyone. The ones that just joined us for the meeting, good morning, good afternoon. Okay, and before we start with the webinar, which is called Tableting of the Intermediate Product, let me inform you about the webinar terms. The headphones, all the participants will be shut down to avoid any interruptions. And in case you have any questions or comment during the presentation, we will proceed the following way. In the lower corner of the menu, you have to choose activities option and then the question answers button. It's the fourth option. And once that the question has been formulated, we will answer it during the intervals for this purpose. Also, during the webinar, we will share with you a survey that we will appreciate if you can answer. It will be 2 or 3 questions. So please proceed to answer, and we will really appreciate it from our side. Now it's time to introduce you once again to the professor of pharmaceutical degree, Mr. Arturo Oya, who is in charge of today's dissertation. Arturo is a very experienced pharmacist. He has large experience in R&D and production area with more than 30 years of experience. So it's really important that you can listen him carefully for this presentation. So Arturo, welcome back once again. And I know that everyone is in good hands today.
Thank you, Mauro, for introducing me. And well, good morning for everyone, and thank you for taking time to hear this 5 of 6 webinar about the solid dosage form technology, the very important question. Well, let me show you the presentation. Here is. Please confirm if you can see it.
Yes, we can see it, Arturo.
Okay, thank you. Well, today, so the webinar is about the tableting of intermediate products, but remember, we have 4 webinars before about how to produce these intermediate products. Let's say by direct compression, by dry granulation, by wet granulation, and something about this, because the intermediate product is very important in this moment when we have to dosify this intermediate product in the unit called tablets. So for me, it's very important this webinar because tableting is not easy. It's a unit operation with a complicated aspect that we need to know and understand. Well, this is the title, Tableting of Intermediate Product. When we say intermediate product, we say blend of powders, blend of granules, blend of pellets, and others. These are a particular system that are transformed by mechanical pressure into monolithic structure called tablets. Well, and our perspective, our vision is that the proper elaboration of the semi-finished product, this intermediate product, is very important. It's very, very important because will define not only the quality of the tablet, but to the tablet production speed. And on that times, the competitive times in the pharma industry is very important to produce at high speed. And if you want to produce at high speed and with high quality, you need to obtain a very adequate intermediate product. This is our vision. And so what do we fit the tableting machine with? Let's say this. Here we have at the left a machine from the 70 years. The production speed was 60,000 tablets per hour. And this is history, of course. Now we have this type of tableting machine, the new generation, the model machine. with production speed is bigger, more than 2,000 tablets per hour. So is the same product intermediate what we need to use in one or the other tablet? This is the question. Can any semi-finished product be processed by this tablet machine? Of course not. Of course not. But what attribute must the semi-finished product, the intermediate product, have to be able to tablet in at that level of speed of 2,000, 3,000 tablets per minute or more? This is the reality actually in these times. So it's very important to be in mind this, because not only we need a good intermediate product, but we have to have a good machine and operate it in a good manner. Well, here we show a linear simulation from the Onis doll. You have this citation. Well, this slide shows the linear rotary press, and as you can see, you have, of course, the hopper in which the intermediate product is introduced, and you have the feeder that help in order to fill the dies during the process. You have the weight control unit here, and you have the pre-compression rolls or wheels and the compression rolls or wheels. Then you have the ejection can. Well, but what we put here in the hopper, well, we need to put a blend with a good density, because as you know, the pharmaceutical powders or granules have a density in the order of 0.5, 0.6 grams cubic centimeter. So it's very important, the density. It's very important, the flowability of the blend. It's very important, the flowability of the blend, because the weight, the tablet weight uniformity depend on the flowability of the blend. We need that the blend has a very good compatibility in order to the mechanical force transform the particle system in a monolithic structure, the tablet, with high tensile strength, high hardness. So the compatibility is the other attributes. And of course, we need that the blend be uniformity, that the components, the API and the other components will be uniformly distributed. So this is the picture that we confront in our study. Okay, so if the semi-finished product, let's say that the blend or granules obtained by wet or dry granulation has adequate properties, so now it's time to tableting it by operating the press machine with, first, the best configuration, the setup, and second, at the maximum production speed. This is very important in that time, the maximum production speed. Remember, in the past, 60,000 per hour was big. Now, in that time, 2,000 tablets per hour is a normal figure. So we need to produce at high speed, and the quality of the tablet would have to be a good quality. This is the frame. So first of all, look at this. This is a Winca machine. Winca machine is elaborated from PATGROUP, and as you can see, the setup of this machine and the adjust variables are these. First of all, we have a turret type, a different turret type, BB standard, B standard, D standard. Filling cams, different filling cams. It's very important to have the different filling cam for each product. Ejection cam, different types, tooling types and size, these are part of the setup of the machine. Of course, we need to define then the target speed in RPM, the feeder speed in RPM, and of course we need to define the thickness of the pre-compression and the thickness of the compression. Remember, when you use a tablet machine, a classic, a conventional tablet machine, what you define is the thickness, the how near is, how close is the upper punch tip and a lower punch tip. So this is what we define with the rolls, with the wheels of the machine. Besides the tablet machine and the variable, adjustable variables, we need to monitoring, to control variables in during the process. And for example, Winca have a compression force monitoring, a pre-compression force monitoring, and ejection force monitoring, and we will try about this in the next slides. Well, but before advance, I wanted to show you the typical problems during tableting. But during tableting, when we operating at high speed production, I insist about this because high speed production is the actual reality. Okay, so which type of pharmacotechnical problem we have? Which is the economical impact of this pharmacotechnical problem? What is the origin of the problem? So the formula or the operation, and which are the solutions? Solution 1 and solution 2, I will see you with are each. For example, weight variation. Of course, all of you have the problem surely about the weight variation tablet. So weight variation tablet have a variable impact during economic variable impact. And the origin of this weight variation in tablet is, of course, low flowability of intermediate product. Is the fair reason. Of course, the solution is improve the flowability. The flowability with the sliding or best excipient filler, etc., etc. But you have another origin. For example, lack of inadequate configuration of the weight control system. In this modern machine, you have a weight control system, and if you configure it in a correct manner, you will have no problem in weight variation. So what we need is configure automatic weight control and monitoring system in the way form. The other origin of weight variation is the asynchrony between the speed of the turret that move the dice and the feeders that move the powder in order to put into the dice. This is possible to adjust if we find the correct synchrony in RPM turret and RPM feeders. So this is an empirical experience that you have to develop. So what you can do, the solution is tune up feeder speed. If you tune up feeder speed, you will reduce the tablet weight variation. But these are the solution 1, the most important. But if you can enhance the tablet variation with this solution, you have a palliative solution. Which is the palliative solution? Of course, reduce tablet speed to increase the filling time. The fill time is the time during which the die load with the powder. So if you can't enhance the problem, you need to reduce the production, and this is not good, but it's a partial solution. Well, the other problem in the pharmacotechnical question is the tablet with low hardness. This is economical, has an economical impact, it's variable, and high variability has an economical impact very high. The same occur with capping of tablet or capping during ejection. These are a problem which origin is that the semi-finished product, the intermediate product, have low compactability, or the blend has a high level of viscoelastic deformation. What is viscoelastic deformation? This is a deformation that depends not only the pressure or the force developing, but the time dependent too. Both of them, pressure and time. So when you have low compactability or high viscoelastic deformation, you have a problem and you need to improve the compactability or reduce the component that have viscoelastic characteristic. For example, you know that crystalline cellulose or starch are fillers that have viscoelastic components. So if you have a formula with high level of this, well, perhaps you will reduce this amount of fillers and replace for other of the type of fragmentary fillers. But if you can solve with this, a palliative solution for this, for example, for low hardness and high friability, is reduce the tableting rate, the speed, in order to increase the dwell time. The dwell time is the time during the punches are in contact, in the maximum contact, to transform powder in the tablet. So if you reduce the velocity, the speed of the turret, you will increase the dwell time, you will have more consistency, more tablet hardness, and reduce the friability. But capping is another question. Capping in tableting and capping at ejection is different. Here, the palliative is reduce not only the speed of tableting, but the force in order to reduce the lamination and the capping tendency. Well, the other problem is a very, very common problem in the industry, the tablet sticking, and produce a very, very high impact in economic impact around the world. So the origin is an inadequate blend lubrication or reduced percentage of lubricant, or in occasion, inadequate tooling state. The punches, the surface of the punches, porous or something like this. So the solution one is, of course, first of all, try to enhance, to improve the blend lubrication, and the other is put new toolings. Of course, the toolings are very expensive, but in occasion it's better this than to have the sticking during the production. And the other solution, a palliative solution, is take the punches and polishing in the best way you can. Well, this is a general description of the pharmacotechnical problems during the compression in high-speed tableting machine. Now, I wanted to speak about the tablet quality and the production speed that will depend about three factors. This is a very important question. First of all, of course, the characteristics, the attributes of the intermediate product. We say density, compatibility, flowability, uniformity, of course. The second is the type and configuration of the tableting machine. This we'll see in the next machine, the type and configuration. And third is how tableting machine is operated. How tableting machine is operated is a very, very important question, because we know that some technical not manage in a way, in an adequate manner, the the configuration and the operated machine. And of course, depends too of the tableting and the ejection force monitoring and control system. The control system is very important in this kind of tablet of last generation. So these are three aspects and a system of control that will or let us to produce in an adequate way. Well, factors, so the synthesis is first intermediate product, then attribute, density, flowability, compatibility, and uniformity. Then tablet the machine, the structure, let's say turret or plate with the number of dies. The filling comes, the depth selection is very important to know how to select the depth selection of the fill coming, or the comes, the weight comes, the cam that control the dosification, the exact dosification of the powder. The feeder is a very important device that defines the velocity of loading the dies. And of course, the tooling is very, very important. The type and the state of the tooling is very, very important. The third factor, of course, the setting to operate. Torque speed, RPM, feeder speed, RPM, pre-compression thickness adjustment, and compression thickness adjustment. These are the factors that we have to do to be in mind in order to best operating performance. Well, now I wanted to show you about or speak about Winca. Winca is a tablet machine of last generation, a model machine with all the device and controls. And I want to show you the parts of this machine manufactured by PATGROUP and the function of this machine. Well, this is the turret with a number of dies. We have different number of dies turret. The feeder is a very important device because, as I said, help in order to fill in the dies. The loading cam is very important because, as you know, what we need is that the die loading with more weight than the target weight. Let's say, if you have a tablet with a target weight of 500 milligrams, well, the loading cam will load, for example, 600 grams, not 500 grams, because in this way, the powder will be assured, and then the dosification cam, the weight control cam, will adjust the needed weight, in this case, 500 milligrams. After the loading and the dosification, we pass to the third step, the pre-compression. Pre-compression means two rolls or two wheels that force the upper punch and the lower punch to near to close in order to evacuate the air into the powder, because, as you know, pharmaceutical powder have densities below 1 and perhaps below 0.5. So much air is into the powders in the blends. So we need to eliminate total or partially, because when we go to the compressor, we don't want to compress air, because if we compress air, for example, some kind of problems in the structure of the tablet could come. So the fourth step is the compression with this kind of rolls. And after the compression, we have the ejection. The ejection is the moment when the upper punch is moving upward and the lower punch is rise, the tablet is ejected and the product is obtained. Here we have for example, the channels in order to obtain the sampler if we need to measure weight, hardness, friability, etc. The channel to discharge to discard the tablet without with the weight out of specification, and the channel with good weight product. This is the general picture of our process. Here, the steps, of course. So, loading, massive loading with the loading cam, dosification, the target loading, the weight of the tablet, pre-compression, the aeration, compression, consolidation of the tablet, ejection, and selection. These are the parts on the function of the Winca machine. Well, but Winca machine, as the same of the all of the machine in the world, is a machine that works at constant thickness. Constant thickness. What that it means? Constant thickness means that when you fix the position of the wheels, the upper wheels and the lower wheels, the distance between the tip of the upper punch and the lower punch into the die will be fixed with a value of h, and all the process will be performed at this h value. This is very important, and you will see what I try to say. Here I show you the wheel, the upper wheel of compression, the lower wheel of compression. Here is the lower punch, the die, and the upper punch. So, which is the thickness or the distance between this point to this point? Okay, the compression thickness configuration H is made by the position of the wheels that define this H. H is constant during all the process of tableting. Which is not constant is the weight of loading, because as you know, flowability have a fluctuation, a minimum fluctuation, but this will impact in the variable weight. Of course, within the specification. But so we have two variables or two factors, H and weight. So the compression force is the compression that will be developed during the compaction. So this compression force is a function of weight, powder weight, and H, the distance between the tips of the lower and upper punches. But if H is constant, as I said before, we note that the compression force now is proportional to the weight of the tablet. And this concept led us to adopt a weight adjustment system that which function is predict the tablet weight using the force that the strain gauge measure. Let's say this. Each compression, each compaction will develop a force that will be measured with a device called strain gauge. Let's suppose you will produce 1 million tablets. Well, you will obtain 1 million force measured by this device, the strain gauge. So if the force is very high, that means that the weight is very high. And if the force measured by the strain gauge is low, that means that the tablet weight is low. So here we know that the weight adjustment, the tablet weight adjustment, depends of the signal that the strain gauge gives to the servo motor in the tablet machine. And this is the conceptual idea of the functioning of the control system. This is the cam to weight adjustment. But which is the relationship between the compression force and the tablet weight? This is force depends in a linear weight, in a linear mode with the weight of the tablet. And let's suppose we have a tablet with a nominal weight 500 milligrams. Well, with 500 milligrams and with H thickness in the compression, for example, the compression force developed is 450 kilograms. It's only an example, for course. If we increase the weight to 525 milligrams, 5%, now the force developed at the same thickness will be 500 kilograms. And if the weight of the tablet is lower, for example, 475, the force developed at this constant H will be 450 kilograms. And this is the idea. We can measure in a permanent loop all the forces developed for each tablet produced. And so this permits us to use a mechanism to select the good and the bad tablets, because the compression force is proportional to the weight. So we have three alternatives. The first alternative is if the compression force fluctuates within the specified tolerance range and with no trends down or trends up, so the machine will not produce no action, because the system is in a steady state, is in regimen, is in a steady state, no action. But the second, is the compression force measured by the strain gauge still within the tolerance, show a tendency, a trend, so the CPO send a signal for the dosifying cam adjustment, and the dosifying cam adjustment control the dosifying, the loading, and correct the variation, the tendency. And the three alternative is what happens if the control force is greater than the maximum control force or is less than the minimum control force specified. In this case, bigger control force means bigger weight, and low control force means lower weight. So the CPU sends a signal in order to discard tablets. So this kind of system give us a warranty, a quality warranty, that all the tablets we obtain are in specification, in weight specification. Let me show you this. This is a normal regimen of compression. The compression force and the times, and these are tablets that produce this variation, but the variation is in the limits and is around beside below. It's a regimen, is steady. But look at this. What happened in this case? Tablets are very good, but in that moment, could this, could this, could this, could this. This is a trend. This is a trend. Is between the limits, the specification limit, but it's a trend. So the machine interpretate that this will go out of specification, and in this case, the dosification wake-up adjustment, the CPU send the signal and say, please, elevation the dosification wake-up, and so the weight of the tablet will come to the normal value here, and the system is normally again. But what happens if we have this point? This point is a tablet, is a tablet with high force. That means a high weight out of specification. So the tablet will be discarded. After this, the regimen is normally and continue as before. This is very important interpretation of the how to work the Winke machine. Okay. Well, so we have this scheme I showed you before, but the strain gauge, the force developed is measured by the strain gauge. The strain gauge send a signal to the CPU. CPU have the control specification. Let's say expected control force, that means weight equivalent of the tablet, and have the CIF compression force tolerance weight. So we have two alternatives. If the compression force measured with the strain gauge is a trend, so the weight regulator adjusts the dosification. The dosification come the weight control. This is a good question. But what happens if we have this situation? This situation means compression force out of a specification. In this case, the loop is this: discard the tablets because the weight is out of specification. And this occurs because the discharge is done by actuating the clapper during a specific arc of rotation, and a train of tablet is the card which ensure that the out-of-weight tablet is discharged. So this batch you produce, all batch you produce is with a weight in a specification, because all the tablets without specification is discarded. Well, I wanted to stop here because I received a question. Mauro, I have a question here about say, what is the ideal tableting machine setup and the critical variable that will allow a production of 200,000 tablets per hour or more? This is a question. Okay, it's a good question. Well, if you want to produce at a production speed of 200,000 tablets per hour, you have to be in mind few consideration. The first one, the very important one, is the appropriate synchrony between the target speed and the feeder speed. The target speed, as you know, define the filling time, and the dwell time. Both these times are very important because the filling time assures the loading of the exact amount of weight. And the dual time assure that the time to transform the powdering in a tablet is appropriate. So you need to define the speed of tablet, and after this, try to obtain the synchrony with the feeder RPM, the velocity. This is the first consideration. The second consideration is to define in a precise way the thickness of the precompressor, and the thickness of the compressor, because this both thickness will define the elimination of air and the develop of the compression force. So these are empirical questions that you will try to obtain. It's trial and error. But when you obtain this condition, then what you want to you need to do is put the automatic control system that we saw before in the best condition. So three aspects in order to optimize the speed of production: the velocity of the turret, the velocity of the speed, the synchrony of both, the adjustment of thickness of precompression and compression, and the optimization of the control system, automatic control system. Well, after this, I want to show you an aspect that not always is considered as important, but in our opinion is too important. Is very important. Is the ejection force. Ejection force is the force required to eject the tablet. Remember, after the compression, the upper punch move up, and the lower punch move upward in order to put the tablet into the surface of the turret and to the ejection. Well, the force required to eject the tablet is a critical measure in the process. Why? Because an excessive value of the ejection force can damage not only the tablet, for example, the famous capping or lamination, but reducing the true life, and it's very important this, and where the ejection can, and of course could stop the machine. We know that the ejection force of the tablet is lower, is very lower than the force we need for compression force. Of course, imagine the ejection force vary between 50 Newton to 100 Newton, but it's very important to be in mind because this level of force could affect in a very critical way the structure of the tablet, the tooling, the cam, and the machine. Here, only to show you, this is the ejection cam, the rotation sense, and of course, the machine, the wing, had a load cell that measured this ejection force. Well, this ejection force is permanently measured and monitoring, and so it's important to be in mind this. What that ejection force depends? Well, depends of this question: the residual force, radial force, this blue arrow. This blue arrow means compression force and non-elastic deformation power. These are the function of this. The friction of coefficient, the die, and the geometry, and thickness and diameter, and the production total speed. These four factors can affect or can modify the ejection force. Of course, you have to reduce all of this using good lubricants, using adjust the production speed. But what you have to do is permanently take a look at the ejection force in order to avoid damage of the machine. Well, here is the very same, the aspect of the ejection force. Here receive a question about, well, the same. The question is, why during tableting process ejection force monitoring is important? Well, as I say, it's important because could affect the integrity of the tablet machine and the product too. So simple. This is the question. This is the question. Well, now I wanted to show you a case study. A case study. This case study is a very particular one because all of us know that the tableting machine are machines to produce high amount of tablet in the industrial pharmacy. Of course, the machine, the use of the machine is for this, for produce at high speed tablet with high quality. But what I want to show you is when you have a Winca tablet machine, you have the opportunity to use the machine as other possibility. You can use the machine in order to quantify the compactability of the powder, of the granules, of the pellets. And remember, compactability is one of the most important attributes that the intermediate product have. And so it's very important to have the possibility to measure the compactability of the semi-elaborated or a semi-finished product or intermediate product. So in this case, I want to show you how to do this in a Winca machine. You have a powder which compactability want to measure and put in the hopper, and then you compress and measure the force needed to obtain the tablet. Then you measure the hardness of the tablet or the tensile strength, and so you have two numbers: tablet hardness and compression force. Then what you have to do is the graph between the hardness tablet, again the compression force. Here is it big. You have here in this X hardness of the tablet. You can graph hardness of the tablet, or you can put the tensile strength, is very normal, and you can put force needed to obtain the tablet, or you can use pressure. Well, which is important in this case study? For example, in this study we use in our university, we know that, for example, the Avicel, the microcrystalline cellulose, pH 101, 200, and 102, show that the dependence of the hardness or tensile strength versus the force or pressure is very same, and the slope is very high. What that means? Oh, if the slope is very high, it means that you need low force in order to obtain a tablet with high hardness or high strength. And this is very important because what you need is that your machine, your tablet machine, works at low level of force. As lower is the force or the pressure the machine make, better is the process, and lower is the wear of the machine, the wear of the tooling machine. So it's very important to have in mind the compatibility. So if you obtain, for example, this line belongs to lactosa tabletosa. Well, here you know that you need a lot of force to obtain a very weak tablet. This is not good compatibility. So if you have a formulation with high level of lactose, perhaps you will need a high level of force, and you will wear the punches, the dies, the combs, and of course the tablet. So this case study only tried to show you the importance or the possibility to use not only for producing tableting, but for characterize or characterize the powder in terms of compactability. Well, finally, I want to show you that the quality of the product and the process efficiency, of course, depend on the technology. The technology is a very important question. We need a good technology, but we know that beyond the technology, the quality and the efficiency of the products or the process depend on particular solution, and the solution for quality and efficiency depends too of this aspect too. The raw material very important, and the formula and the manufacturing process. And in both cases, we need solution that give the raw material and formula means, please select a good raw material, purchase specification, the composition quantitative of our formula, use a formulation tips, expertise, and if you will operate the process, you will have to configure the production line in a very optimal condition, define the process variable setting and the scale up if you need, and define the specific application, and of course use the methodological tips that enhance the process and use the expertise. All of this solution PATGROUP offers you to, if you need. So it's not only a problem of technology, it's technology, raw material, formula, and process manufacturing. Well, for my part is all I want to say you, and I thank you for your attention and wait for your question. Thank you very much.
Thank you, Arturo, for this exposition. It has been really, really interesting. So I hope everyone could have listened carefully. I would like to remind every one of you that we have the 6th and the last webinar on July 21st, which is related tablet coating. So you will receive the invitation there in the following days. So we hope you can join us. And also our marketing team will share with you the marketing material for the PDF and the webinars that we have record for this presentation. Okay. Now, Arturo, we have one question for you from Mr. Burak. He asked, what is the main advantage of using servo motors for compression comparing to conventional roll compression?
Okay, the servo motor, what we have is an automatic control of the pressure, and the question is compared with
conventional roll compression. What is the advantage of using servo motor for compression comparing to conventional roll compressions?
Okay. We say roller compactor is the best way to obtain the granules, the dry granules, and you can use this system, the tableting machine, the typical tableting machine, to produce slugging, but the problem is you will use the tableting machine, and occupies time to obtain compact that then you will ground to produce the granules, and well, you lost time. Another question is, another problem is that when you use the tableting machine to produce dry granulation, is the variability, because you use a constant weight. So it's a constant weight, but you have a fluctuation weight. Well, of course, the slugging, the compact will vary in the hardness, and the particle size distribution will be very, very wide, and so the flowability will not good as if you produce with a compactor, a royal compactor. This is the I think the most important.
Okay. Thank you, Arturo. I would like to remind everyone that we have activated the survey on the screen, so we're gonna appreciate if you can answer before we finish with this webinar. We are already on time, so unfortunately we don't have more time for questions. In case you have any comments, you can please share it with us to our email, which is info@patgroup-sa.com. And again, I would like to remind you the last webinar will be on July 21st, and everyone is most than welcome to participate, okay? So, well, Arturo, thank you very much once again for this exhibition.
Thank you, Mauro. Thank you all.
Really interesting. And well, thank you everyone else for participating once again with us. Yes, have a nice day. Yeah. Thanks, Burak. Thank you, Anna. Have a nice evening.
Hola.